Hello, and welcome to Curious Planet. This video is part of my Geology Foundation series. The goal of this series is to lay the groundwork for future videos and for your own adventures. Today, we're talking about sedimentary rocks. Barring a few exceptions that we'll talk about, sedimentary rocks can be thought about rocks made of other rocks. Over time, wind, water, and chemical reactions break down the landscape into smaller and smaller pieces, eventually forming sediment, which is then transported and deposited elsewhere in layers. These layers are then buried and compacted until they form solid rock. Sedimentary rocks like this, those that are made from the broken down pieces of other rocks, are called detrital rocks, from the word detritus, or clastic rocks, because the sediments within the rock are called clasts. And in many cases, the clast size determines the rock type, ranging from coarse-grained like a sandstone to fine-grained like a silt or a claystone. Notice how, even though they're small, you can still see the grains in this sandstone, whereas the grains in this shale are too small to be seen with the naked eye. You can, however, spot a trilobite fossil, which is pretty cool if you ask me. Sometimes clasts are smooth and rounded, like this conglomerate. This indicates that they've traveled a long way to get to where they are now, bumping into things and smoothing out their rough edges. River rocks are a really good example of this. Other clasts may be jagged and angular, like the ones in this breccia. These rocks haven't come so far and were likely deposited all at once in something like a landslide. And you can get even more information about a rock's origin by looking at its mineralogy. For example, this sandstone has a lot of quartz in it. And since we know that quartz is a hard, durable mineral, we can tell that the sand that makes this rock has come a long way to be here, losing any less durable minerals that it may have had along the way. Whereas this sandstone has more feldspar in it, which erodes more easily. Therefore, we might assume that it hasn't traveled as far, and that we may have found this rock closer to its source. The original source of the sediment in a rock is called its provenance. Another thing that the clasts in a rock can tell you is how much energy its depositional environment had. Generally, fine-grained rocks like siltstone, claystone, or shale were deposited in low-energy depositional environments, whereas coarse-grained rocks like sandstone or conglomerate were deposited in high-energy depositional environments. Think about it. In a high-energy depositional environment, like a fast-moving river or the crashing waves on a beach, the rushing water will wash away any fine sediment, only leaving the clasts that are too large to be moved by the water. Compare this to the bottom of a lake or a deep seabed, where the water is very still, and fine-grained sediments that are in suspension are allowed to settle out and be deposited on the bottom. So far, we've been talking about clastic sedimentary rocks. Remember, rocks made of other rocks. Most rocks are clastic, made from the mechanical breakdown and redeposition of sediment. But at the top of the video, I did mention there were some exceptions. Sedimentary rocks can also form from chemical and biological processes. One example is carbonate rocks, like limestone, which form in underwater environments with excess calcium carbonate. This excess calcium carbonate either precipitates out of suspension in the water column, or it is used by a variety of living organisms, like coral, to build their skeletal structures, which are then later broken down into sediment. Organic rocks form from ancient organic material, like plants or algae, which is then buried and pressed into a deposit. This is how coal forms. And with enough heat and pressure, the coal will become denser and more refined until it turns into graphite, and then diamond. I think sedimentary rocks are fascinating because their relationship with one another can tell a story in surprising detail about what was happening in one place on Earth over many millions of years. And the concepts that tell these stories really deserve their own video, so stay tuned. As always, leave your questions and suggestions below, and until next time, stay curious.